Let us now discuss how to generate combination of certain array elements. Let's consider a string ABC as an example. So this is nothing but a char array. How many characters are there? 3 characters are there. So what is the number of combinations possible? The characters. There are 7 combinations possible. So how did we arrive at that? It is easy. There are 3 characters. So to find the number of combinations possible, 2 power the number of characters. Here it is 3 minus 1. So it is nothing but 8 minus 1, which is 7. We can verify that also. So first let us take the combination of 1 character each. So what are the combinations possible? A alone, B alone, C alone. Now we are going to consider the combination of 2 characters. So what are the combinations possible? AB, AC, BC. You are not going to say BA because we are not considering the permutation but only the combination. Then 3 characters ABC. This is same as BAC, BCA or CAB or CBA. So because here we are considering only the combination and not the permutation, so totally we have 7 combinations possible. So this 7 we can easily calculate as 2 power 3 minus 1, which is 8 minus 1, it is 7. Now what is the approach we can follow to generate these combinations? So now we have A, B, C. Let us write down the index values. So the index value for A is 0, for B is 1 and for C it is 2. Now what is the length? Length is equal to 3. So what is 2 power 3 minus 1? It is 7. So 7 such combinations are possible. So let us write down the numbers 1 to 7. 1, 2, 3, 4, 5, 6, 7. Now because the length is 3, consider 3 bits alone. That is, the bits before will be 0. So what is a binary representation for 1? For 1 it is 0, 0, 1. Because anyway the bits before also will be 0. Because the length is 3, we are considering only the last 3 bits. For 2 it is 0, 1, 0. For 3 it is 0, 1, 1. For 4 it is 1, 0, 0. For 5 it is 1, 0, 1. For 6 it is 1, 1, 0. For 7 it is 1, 1, 1. So why have we written the binary representation from 1 to 7? Because if you observe the binary representation, wherever 1 is there, pick the corresponding character in the string. Then you will get all the combinations. So let's consider 1. So where is 1? Here it is there. What is the corresponding character? C. So you can write down C. Now for 2, where is 1? It is in the middle. What is the corresponding character? B. So you write down B. Now consider 3. The last 2 bits are 1. What are the corresponding characters? BC. So write BC. Then for 4, it is 1, 0, 0. So 1 is here. What is the corresponding character? A. So write down A. For 5, first and last bits are 1. What are the corresponding characters? A and C. So write down A, C. For 6, first 2 bits are 1. So what are the corresponding characters? AB. So write down AB. For 7, all the 3 bits are 1. What are the corresponding characters? ABC. So write ABC. Now if we observe the characters, we have got all the possible combinations. Single character combination, we have got A, B, C. Then two characters combination, we have got AB, BC, CA, right? AB, AC is there, BC is there. And three characters combination, we have got ABC. So this is how we are going to generate. So the logic is, whatever the length of the array, string is also a char array. So for the length, you traverse from 1 till 2 power length minus 1, that integer values. So in that integer value, wherever 1 is there, that is a set bit is there in the binary representation, consider the characters or the array element values in that position. If you consider all those array element values, then you will get the all possible combinations finally. So this is how we can generate the all possible combinations. So let us perform this logic in C programming language. That is, accept a string which is nothing but a char array, print all possible combinations of the characters. So they may not be in the proper order, that is, it will not be like A, B, C, but whatever order it is there, it is fine. But it will print all the possible combinations. So let us implement the logic we discussed. So to begin with, let us accept the string value as the input. So the maximum length of the string will be 20 characters. If you want to consider the null character, you can make it 21. So now we need to find the length of the string. So now we need to calculate 2 power len minus 1. So how to calculate 2 power len? Already we have discussed about left shift operator. So 1 left shift len will give you 2 power len, okay, minus 1 we can make use. So the integer values must be from 1 to 2 power len minus 1. So instead of saying less than or equal to, we can say less than 2 power len. So how will you calculate 2 power len? 1 left shift len. Because we have told val is less than 1 left shift len, it will actually be 2 power len minus 1. That is till that it will go. Because if you say 2 power 3, it is 8. If you say less than 8, it means it can go up to 7. So now we have got the integer value of the counter in the variable val. Now we need to check each bit. That is whether it is 1 or 0. If it is 1, then we have to print the character at the corresponding position in the string value str. So how to check if a corresponding bit is 1 or 0? So we can use bitwise AND. So let me explain. Suppose you are having the value as 9. So the binary representation of 9 is 1, 0, 0, 1. So how will you check if the last bit is 1? You have to use 1 left shift 0. So 1 left shift 0 is nothing but 1 itself, because you are not shifting anything. So you have to make a binary AND operation. So when you make a binary AND operation, assume all other things will be 0. So it will give you 1. That is a value which is greater than 0. So if the value is greater than 0, you know that the bit is set there. Now how to check if the second bit from the end is 1? Consider the same 1, 0, 0, 1. You have to left shift 1 by 1. So it will give you 1, 0. Right? So when you are doing a binary AND with this, you will get 0 here, because the AND truth table is only if both the bits are 1, it will give you 1. Here both the bits are not 1, so it is 0. Here also it is 0, here also it is 0. So 0 means it is false. That is, a value is not greater than 0. It is equal to 0. So in C it is false. So if it is false, you know the bit is 0 over there. So we can verify that also. Here it is 0. So now how to check that the third bit from the end is 1? So 1 0 0 1. You left shift it by 2. So it becomes 1 0 0. So now when you do a binary AND, so it is 0 0 0 0. So now again you know the third bit from the end is also 0. You can verify that by looking at this. Now how to check the fourth bit from the end, because we are going from the end, because we can use left shift operator and figure it out. So now you will say 1 left shift 3, which is nothing but 1 0 0. So now again 1 0 0 1, and you are going to AND with 1 0 0 0. So now it is 0 0 0, but here because both the bits are 1, you will get a 1. So the value is greater than 0. So you know that the bit is set there. So this is how we can figure it out. That is, left shift 1 and check that bit position, right? So that is what we are going to do here. Here, till what should you left shift here? You see that it is 0 initially, then 1, then 2, then 3. So how many times should you left shift? You should left shift from 0 till the length, whatever the length is there. Because here the length of the value can go up to 15. You have 4 bits. So 15 is nothing but 2 power 4 minus 1, right? So 0 till len minus 1 you have to go. That many times you have to left shift and check. So here it is len, so it has to go till len minus 1. So now we will have another loop to check the bits in the binary representation of the value. We will say bit position from end. Initially it will be 0, which means it is not being left shifted. So we will just say bit position, okay. So till what it must go? It must go till len minus 1. So we say bit position less than len, because less than len means it will be going till len minus 1. Bit position plus plus. So now what are we going to do? We are going to do a binary AND after left shifting 1 by the bit position. So we are going to check if val AND, right, bitwise AND. With what are you going to do an AND? You are going to left shift 1. By how many bits are you going to left shift? You are going to left shift bit position times. So if this value is non-zero, then you can consider the character at that bit position, right? So we can say printf, because we are going to finally print the combination. So printf %C, the string value at that particular index, okay? So what is the index? It is nothing but the bit position value. So it will print the characters in all the set bits. So that is one particular string. So after this for loop ends, to print the next string in the next line, you have to print a new line. So new line is indicated by \n. So now we have implemented the program. Let us execute it. So let's give ABC. So we can see the single letter combination ABC, AB, AC, BC and ABC. So now let's give one more example. We are going to give ABCD. So we will have 15 combinations because there are 4 characters. So 2 power 4 minus 1. So AB, CD is there. AB, AC, AD is there. Then again the other combinations BC, BD, everything is there. Let us give one more example. We will give cat. So we can see all the combinations coming up, all the 7 combinations. And we can give lemon. So we can see 2 power 5 minus 1, 31 combinations being printed. So based on our discussion, please solve the program.